Historically, research has seen Indigenous peoples, their lives, and their practices as something to be researched by outsiders. This kind of research is harmful and does nothing to assist tribal nations in building towards their future. In the Great Lakes Basin, the Anishinaabe are fishing people. Many of their traditions and foodways are connected to fish, such as walleye. Fish contamination is ubiquitous, causing fish consumption advisories which recommend limiting the amount of fish consumed, especially top predators like walleye. While these advisories are intended to protect human health, they contradict treaty rights, which legally protect the Anishinaabes' right to fish throughout the region. Additionally, these advisories only consider individual contaminants, such as mercury and PCBs, despite evidence that some of the chemicals have synergistic or antagonistic toxic effects. My dissertation is a collaboration with the Keweenaw Bay Indian community to address one of their primary concerns, fish contamination, specifically how mixture toxicity affects their ability to safely consume fish. To conduct this research in a good way, we created a conceptual model to guide collaboration with the KBIC. Through the seasons of research, all participants are engaging with each other and with one of the seasons while also considering the others. By building relationships, planning with KBIC priorities in mind, exchanging knowledge regularly, and synthesizing and applying what's been learned, Indigenous knowledge and Western science can be bridged to address community needs. Putting this framework into practice, I will use quantitative methods to evaluate patterns in combined toxicity by exploring the environmental dimensions that influence chemical bioaccumulation and toxicity. Using these national patterns, we'll model mixture toxicity locally in frequently fished but unmonitored lakes within the region, specifically water bodies that are important to KBIC members. Finally, using policy analysis, we will explore the efficacy of federal policies in decreasing contaminant concentrations in fish. Collectively, this work will advance our scientific understanding of mixture toxicity so that we can establish safe advisories to protect human health and better understand the time scale and spatial scale necessary for policies to influence fish tissue concentrations.